All right, so video just going over stoic problem or two. All right, so I got some practice problems here. We'll take that and do it and hopefully make sense of it. So, oh, excuse me. So we have this prompt here, right? And this kind of stoic problem, start out with, no limiting reagent. There's no molarity or anything like that. This is just like a basic stoic problem. Okay, you're given grams of something. The assumption is you have enough grams of the other reagent. In this case, we'd say excess, which means I have enough. So if I run out of one thing, I know I'm going to have enough of the other. That simplifies things for us, okay? Because this can get worse when you have to figure out which one's going to run out first, right? And that's different. That's called the limiting reagent problem. That's harder, but we'll get to that eventually. For these, though, hopefully we're practiced these before, or if this is your first time seeing it, hopefully you're like, okay, this video makes sense to explain it. So I got to take this problem, I got to convert it into chemistry, I often say, aka make it into a reaction. Okay, so if I look at this, sodium chloride is NaCl. Oops, let's try. No, that's not what I want. No. My computer's not being very nice to me. All right, let's try it again. Here we go. Or rather my pen, this pen thing I'm using. It's pretty cool, but it's not perfect. NaCl, sodium chloride, and then it's reacting with iron. There's a typo here. It should say excess, right? Excess iron 2 oxide, but it's fine. Iron 2 oxide is FeO. It's an ugly molecule. That's my joke of the day. So then this is going to make something. What's it going to make? It's a double replacement reaction. So we're going to swap the cation for cation, or you could say swap anion for anion. It doesn't make a difference as long as it's a positive with a negative. And again, positive should always be first. So we're going to make sodium sodium oxide, right? And sodium oxide is going to be Na2O, 2 sodiums, 1 oxygen, right? And then we're going to make some iron chloride, iron 2 chloride to be exact, right? FeCl2. All right, and then I can balance this, right? For balancing this, we just needed 2 here, it looks like, right? 2 sodiums, 2 sodiums, 2 chlorines, 2 chlorines, 1 iron, 1 iron, 1 oxygen, 1 oxygen. We're going to go. Molar masses, I should find those. Okay, I guess I'll switch colors over here. So I got NaCl. I got FeO. I got Na2O, the sodium oxide, sorry, and I got iron 2 chloride, FeCl2. Again, for molar masses, hopefully you're comfortable with this at this point. So let's see. Sodium chloride is like 58 and change, but let's get the exact number. So quickly do some math here. 58.44. Okay, good. 58.44 grams per mole. The FeO, 55.845 plus, what did I say? Oh yeah, it's actually 15.999. 71.844. 71.844 grams per mole. The Na2O times 2 plus 15.999. 61.979. 61.979 grams per mole. And iron 2 chloride. Oops, 35 point that. And I get 126.745. That looks right. 126.745 grams per mole. All right, and now we can cook. The problem is asking for everything, right? It says find the grams of products. Well, these would be the products, right? So I got to find the grams of those. And it says find the grams of the iron 2 oxide. So I basically just have to find everything, okay? Just do some work. Not that bad, at least I hope not. So to do this, we're going to take, let's see, we are going to have, starting out, our 89.22 grams of sodium chloride. Put it in our fence, our wavy fence apparently. I've got to convert to moles first. Use the molar mass of the sodium chloride. 1 mole of NaCl is 58.44, right? Grams of salt. And now we got to choose what we want to find first. It does not make a difference. If I'm finding everything, I mean, you could start wherever you want. I would just go left to right because why not? So first we're going to find FeO. What's the ratio? The ratio is one of these for every two of these. So there's 2 moles of NaCl in the numerator or denominator. Sorry, that cancels that out. And then 1 mole of FeO. Okay. This is going to find the moles of this, and then I can convert to grams. I use the molar mass. The molar mass for FeO is the 71.844 grams of it per every mole of it, right? And again, you'll notice I use the labels just to keep things clear, okay? And what's my answer for this? I don't know. Let's see. Let's put it in the calculator. Let's take a look. 89.22. And the assumption, of course, is that you know how to multiply the fractions, okay? If you're not comfortable with that, you need to remedy that, okay? Multiplying numerators across, dividing by denominators across, right? Or doing 89.22 divided by 58.44 times 1 times 1 divided by, like, there's different ways you could do it, right? But, just please, for the love of God, do not do cross multiplication. Don't do it. Don't even think about doing it because it's wrong. It doesn't work. So please make sure you keep that in mind, because a lot of people think you should, and it does not work. It's not a preference. It's a literal, it will not work mathematically. You'll get the wrong answer, and you'll feel silly. Anyway, I was in the middle of doing this problem, wasn't I? And then I started haranguing you to not cross-multiply. Anyway, okay, so what do we get? We get 54.842, I'll say. I'm going to round to the thousandth place in this case. 54.842. 842 grams of FeO. Okay, so that's one answer. Hooray! Got 2 more to go, so I'll switch colors here, I guess. Orange time, why not? It is orange season, after all. It is January and February, good time for oranges. All right, anyway, back to this. Hey, we're going to start again. 89.22 grams of sodium chloride. Put it in my fence. 1 mole of sodium chloride. Again, these problems hopefully aren't that bad because you're like, oh, once I get one of them done, the rest kind of fall into place. Just slight differences, right? These first 2 steps here look identical, right? Because they are. And now let's maybe find the sodium oxide. So the ratio happens to be 1 and 2 again. 1 of those to 2 of the sodium chloride, right? So 1 mole of the sodium oxide per every 2 moles of the NaCl. And lastly, molar mass. This is Na2O, the sodium oxide. That molar mass we found to be 61.979 grams of sodium chloride per every mole of, or not sodium chloride, sorry, sodium oxide. So you got to be careful, right? Easy, you can see how easy it is to oh, sodium, yeah, that. Just make sure you're getting the right ones, right? 61.979 grams of that, sodium oxide per mole of sodium oxide. Okay, what do we get? Let's find out. 89.22. Times 61.979, we get 47.311. Again, I'm rounding to the hundredths place, or thousandth place, sorry, grams of the sodium oxide, Na2O. Okay, and we got the last one, I guess green, because why not? Same thing, 89.22 grams of sodium chloride. Oh my god, that was horrible. Let's try that again. Well, no, I need to... Actually, aha, look at that. Fancy. All right, anyway, back to that. Not the best fence, but we'll make it work. It'll keep the cows in. All right, 1 mole of sodium chloride per 58.4. It's almost like we're losing our minds repeating this, but we're almost done with it, so it's not that bad. The ratio happens to be 1 to 2 again, right? Pretty nice. Makes it easy for us. 1 mole of the iron 2 chloride per every 2 moles of the sodium chloride. All right. And then lastly, molar mass. The molar mass we found to be 126.745, I think that's what I wrote. Ooh, it's a little nasty. 745, I believe. Okay, grams of the iron 2 chloride, FeCl2, per mole of iron 2 chloride. And what do we get? Let's find out. Let's see. It's going to be somewhere in the neighborhood of... do I want to do this math in my head? I don't think I do. I'll just get the answer. There's a shortcut for checking our work, right? I'm trying to do that in my head, but my brain is not braining right now. So that's okay. All right, divided by that, multiplied by that. Oops, 126.745. 96.750 grams of the iron 2 chloride. And we can check our work. You have these answers. Now, notice, I mean, this is kind of messy, right? You're probably looking, oh my God. Thankfully, I have the different colors here, right? If you look at my answers, right, I have the grams of the iron oxide, I have the grams of the sodium oxide, and I have the grams of the iron chloride, right? Those are my three answers, okay? What I can do is take that information and work with the reaction, aka how many grams of reactants makes how many grams of product, okay? So, let's see. I guess red will stick out nice here, maybe. How many grams of sodium chloride? Well, that's right there, 89.22 grams. And we're adding a certain number of grams of iron oxide, and we found that, right, 54.842. Okay, these together are going to give us a number if I add them together, right? So it says right there, it says to add them, so let's add them. 89.22 plus 54.842. And I get 144, so a total of 144.062 grams. That is the total grams on the left side. The right side, the product side, better add up to that number, or very, 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 very close to that number. Maybe instead of 144.062, maybe it's 144.061. Because we've been rounding, that's possible, okay? But it better be close, so let's see. The sodium oxide, we said, 47.311 grams. Adding, right, hence the plus. 96.750 grams of the iron chloride. Add those together, what do we get? Let's find out. 47.311 plus 96.750. And we get 144. Wow, that's actually kind of funny that I said that number. 144.061 grams, and you're like, okay, those are pretty much the same. Okay, you might say again, what about this? It's because you rounded, perfectly fine. Okay, as long as it's that close, you are in great shape. This is good evidence that we're probably correct. Okay, so that's it. Okay, and you say those are my answers, right? So I have grams of this, grams of that, grams of that. I can check my work, and I say it looks good. We've proven the conservation of mass, which is important. All right, so this video, just to keep it kind of short, this is one solution, right? You got to practice these though. Okay, you can't just watch me do it once and say, oh, I'm an expert. It might feel like that when you first started, like you're like, okay, I watched it, I get it. You need to see it a bunch of times, okay? And a lot of steps, as you can hopefully agree, that if you're not careful, can go wrong very quickly. Okay, so please make sure you're practicing. Anyway, have a great rest of your day.